Hi, in this video, I will show you how to load data present in AWS S3 bucket into um, AWS RDS Aurora Serverless version 2 database, which will be sitting in a VPC with using AWS Lambda. As you see in this picture, here I have two services, which is Amazon S3 bucket and also RDS Aurora PostgreSQL serverless version 2 database. Now Amazon S3 bucket is acting as a source of data where raw data comes and sits on this Amazon S3 bucket. Now you need that data to be uploaded into or to be imported into RDS Aurora PostgreSQL database. Okay, let's say this is a scenario. In this case, this is my video which is dedicated for that. Okay, so here it has multiple security concepts. Okay, when I say security concept, in the sense the RDS Aurora PostgreSQL database is integrated with the VPC. In the sense, this database is accessible within a VPC. Yeah, and also now the orchestrator, in the sense the AWS Lambda, which processes nothing but which processes the source data, which will pull out the source data from Amazon S3 bucket and put it into RDS database, RDS Aurora database. So that Lambda is also need to sit in a same VPC so that it can easily communicate with the RDS Aurora PostgreSQL database. Okay. Yeah, so that's the reason here, as you see in this picture, I have kept the AWS Lambda within a same VPC as RDS Aurora PostgreSQL. Okay. Now again, Amazon S3 bucket. Okay, so Amazon S3 bucket, which is sitting, okay, which is a global service and it is sitting outside the VPC as well. So in that case, how does this AWS Lambda has to access the Amazon S3 bucket? Now in that case, I will be doing a VPC endpoint. Okay, so I will be enabling a VPC endpoint on this VPC targeting to Amazon S3 bucket. Yeah. Okay, so with that endpoint, the AWS Lambda can automatically communicate to the Amazon S3 bucket and download the file from there. Then it processes that file or reads the data from the file and uploads into the RDS Aurora PostgreSQL database into a particular table. Okay, so this is just a brief overview. Now what I do is I will walk you through these components configurations one after the other, and finally I will show you a demo in regards to this complete scenario. Yeah, the here scenario is, let's say that you have a business case or you have a business application which is uploading the raw data files like CSV file or JSON file oftenly, okay, into Amazon S3 bucket. Yeah, and that data has to be extracted from there and it has to be uploaded into RDS Aurora PostgreSQL serverless version 2, yeah, which is the latest version. So in this case, this is a scenario which is rightly fits for you. Yeah. So before I walk you through the next steps of this video, a kind request, please do subscribe my channel. That would really encourage me a lot. So yeah. So with that note, let's directly jump to this video. First of all, let me show you how did I configure the RDS Aurora PostgreSQL serverless database. Yeah. So I'm in this is my AWS account first of all. Yeah. And this is Amazon RDS service pane, and currently I'm in a Mumbai region, that is AP South 1 region of AWS. Okay, so in this one, as you see in this picture, I have pre-created the databases because creating the serverless database in RDS, it takes like nearby 10 to 5 minutes. Yeah, 5 to 10 minutes. Yeah, so in this case, I have pre-created this database, and you see the engine. Okay, the engine which I choose is Aurora PostgreSQL. Yeah, and the size you see is the serverless version 2. Now, so my my cluster and the right instance, yeah, our database instance is up and running fine. You see the status is available. This is nothing but it is already configured. But for your case, to help you, I will show you the steps that how you need to create those database. Just go and click on a create database. Yeah, and here you need to choose these options. Okay, for example, so here create a standard one. Yeah, choose the creation method. Let's select the standard create, then go to the engine type. So here it is very important, so we should be choosing Amazon Aurora. Yeah, and in this one, since I'm using the flavor of PostgreSQL compatible edition, so I will be choosing this one. Yeah, and after that there is a one more trick here. Okay, so if you scroll down, yeah, so there is a show filter. In the show filter, we have to choose this version. Yeah, show version that suppose serverless. Okay, why does people go for serverless? In the sense, which is, serverless brings you lots of advantages. You don't need to break your head to manage the backend infrastructure and all. Yeah, so that is the reason people will go for a serverless, capabilities. Like it can be database or it can be, web server, anything. Yeah, so here we are going for serverless. Yeah, serverless version 2. Yeah, so once you choose this filter, then you will have the available options as of now. That is a PostgreSQL 13.3, which is the latest version. Yeah. All right. So with that, now let's go down and select the further one. So here the templates are for production and dev test. For example, if you are performing in dev test environment, maybe you need to choose this option. If you are performing in the production, maybe you need to choose this option. Yeah. And after that, cluster identifier. Okay. So here you need to give your cluster name. Whatever the name you give here will be replicated as your cluster name. All right. Then let's go down, and here is the place where you need to give the credentials data. So these are the login credentials. Okay. For example, once you have set your cluster and let's say your database instance is up and running fine, to access the PostgreSQL service, yeah, or a database service, then you should be having service logon. Yeah, that is a database PostgreSQL logon. Okay, so this is the credentials that you will be using. Okay, this is the first and foremost credentials that you will be available to you as a super user. Okay, in simple term. Yeah, so here the master username is something like by default they will give it as a Postgres. Maybe later you can confirm your master passwords. Yeah. So master, while you are creating master password, I will recommend you to create a very strong one. Okay. So in my case, while I am creating that, I have noted down my password and user ID. So you see, this is my username and this is my password. Okay, which is very secure password. Yeah. All right. Okay. So once the password is been set, now let's go to the down. Yeah. And here you go. By default, when you choose a serverless, then it is DB instance class will be chosen as a serverless. Yeah. The version is latest one, that is a serverless version 2. Okay, after that the range capacity, yeah, the capacity range in the sense how much the your DB instance resources should have. Okay, for example, how much CP core you need to have and how much memory you need to have. So such configurations you will maintain at the capacity range. Okay, minimum ACU and maximum ACU capacity will be given here. Yeah, and after that you are setting the availability and durability options. Okay, whatever available here. Then let's go to the next one, that is a connectivity part. Okay, this is very important one. Yeah, when you are creating, okay, when you are creating any kind of RDS instances, RDS database, we should be keeping, yeah, we should be keeping those database instances or database cluster in a VPC of AWS account. Okay, VPC is nothing but virtual virtual private cloud, yeah, which is a virtual network service. Okay, so here by default each region will have its own default VPC. That's henceforth you will be seeing these VPCs being listed. Okay, nothing but VPCs being created in this Mumbai region will be listed here. Yeah. All right. So and after that you will be selecting a subnets belongs to that VPC. Yeah. And after that, this is very important concept, that is a public access. So what does that public access means? In the sense, you can if you select yes, then in the sense you will be able to connect it to your database instance from the internet. Okay. If you select no, in the sense you are only allowed to access the database instance within the VPC only. Okay. So for security purpose, it's always recommended to keep it no, because so that your application access the database or makes the transaction with the database within the VPC only. Okay, so that is very secure one. Okay, if you expect to the public, probably there is a chances of getting hacked. Okay, your data might get hacked one. Yeah, so that's the reason it's recommended to always keep it no. In my case, what I did is I first created the database instance as public access. Yes, I set the I set the databases. I will show you how did I set. And after that I changed back. Okay, you can do a toggling, you can make it public and then you can remove the public, that is allowed. Okay, first I made it as a public, I created a database, I created a table within the database, then I reverted back into the public access equal to no. Okay, so that also we can do. Okay, all right, now let's go to the VPC security group. So this is the security group we will be choosing. Yeah, and after that in the additional settings, yeah, in the additional settings, the ports. Okay, so this is by default PostgreSQL port number, that is 5432. Yeah, and after that rest option you can keep it default. And when you go down in the additional configurations, okay, so here is the thing, here is the option, by default you can create a database instance dedicated for your application here itself. Yeah, on the go itself, in the sense on the go of while you create a cluster for your database, you can create for your database instance, you can create a database within your instance. Okay, so this is, if you put your database name here, that will become your database. Yeah, in my case I have put on there, so I have put my database name there, and my database got created as well. Yeah, all right. The rest option I have kept it as requested, like a backup one, then encryption one. Yeah, and monitoring one, log export. Yeah, maintenance configurations, etc., etc. So keep these configurations as per your business need, and finally click on create. Okay, once you click on create, it will take nearby 10 minutes. I would say it will take 10 minutes, and finally it will create, it will create the number of instances that you have chosen. So that many number of instances will be created here, and you will have one cluster. Okay, in this case I have chosen dev test environment. Okay, because I'm just just demoing this scenarios. Okay, that's the reason I have only one write instance. Might be in your case you might have more than one write instances. Okay, so as you see the engine, you see the engine should be Aurora PostgreSQL, and the role should be regional cluster and write instance. Okay, regional cluster is nothing but it's a service which will help you to make your database instance highly available. Okay, that is what the cluster tells. Okay, it's a group of instance. Through that you are making service highly available. Okay, all right. And then we have the instance size, and you see that this is the size is serverless version 2. Okay, yeah, all right. So this is the configuration I did. Now I will go to the next level. Okay, right now what we did is, let me go to my figure here. So you see we have set with the Aurora DB in a VPC. Now I will show you the VPC configurations. Okay, if I open this instance, so here you see multiple networking concepts. Okay, you see in the networking, yeah, we have a VPC which is a default VPC, and it is also been tagged to a 3 subnets and default subnet group as well. Yeah, yeah, and we have a security group. Okay, that is a VPC security group, that is SG. Yeah, and that is a default SG. Okay, so now what I do is I will open this SG, and I will also show you that what are the default inbound and outbound configurations are being maintained. Okay, I will show you that it is not being exposed to the internet. Okay, so if I go down and if I edit the inbound, you see right, so it has 2 inbound rules. One is source is nothing but the security group itself, and it is targeting, in the sense within the security group we are allowing all the networks. What does this means? It means that within the VPC you are allowing all the port communication. Okay, all the ports are being allowed, all 2 and 4 communication is allowed within the VPC. That is what the last rule tells. Okay, but if you go to the above rule, so here we are allowing port number 5432, which is a port number of PostgreSQL, from the source nothing but my VPC size. Okay, this is my VPC CIDR. From that CIDR, we are allowing the port number 5432. Yeah, so these are the configurations I have maintained at the default VPC security groups. Yeah, all right. So this is the configurations that is I have maintained at my database side. Okay, yeah, now I believe that you are pretty much clear. So now let's go to the next component. Okay, so I will also explain. Okay, before I go to the next component, I need to explain you one more thing, very very important one. Okay, so right now let's say you have created the cluster, and your cluster status are up and running fine. Okay, but that is not enough. Why it is not enough? In the sense, this is a cluster. Under that cluster you have one instance, that is instance is nothing but a EC2 instance. Okay, EC2 machine. In that EC2 machine, you will have PostgreSQL service or PostgreSQL application running, yeah, which is nothing but a database application. Yeah, so by default when we created the cluster, we have a database. Okay, we have created a database. Now we need to go to the database and we need to create a table which is needed for our data import. Okay, that is the next scenario. Now I will show you how did I do that. So as I explained earlier, I first made the my cluster as a public accessible. Then I used PG admin utility or the client. Okay, this is my PostgreSQL client. I leveraged the PostgreSQL client and I connected to that my cluster. Okay, by providing user ID password, then by providing the right instance, okay, so by providing this endpoint, okay, so by providing this endpoint, yeah, and these user ID and password, yeah, and the port number 5432, then at the end, I was able to make a connection. So if I go down, go above, you see this is the connection I made, okay, this is the server connection I made, okay. If I go down, go to my dashboard, okay, so if I go my dashboard, since this has been bit delayed, that's the reason, it has lost the session. So that's the reason it's taking some time. So if I go back to the dashboard, so you see this is the PG admin, okay, nothing but it's a PostgreSQL client, okay. So it's currently loading. So you see I have configured a server called AWS RDS Aurora. So that is a server connection I did from the PG admin by providing the credentials like host name, port name, username, and password. Okay, at the end I was able to access it from the internet. Okay, my laptop is nothing but internet. Yeah, so I was able to access the database from the internet. Okay. Now, after that, what I did is, as I explained, I have created a database. Okay, you see the database is vehicle is created from there. Yeah. So if I expand this database, yeah, so this is the database which is created for my use case. And after that, okay, after that, I went to the, so let me go to this one. Yeah, I went to the, I selected this database and I executed a command called something like this. Yeah. So if I go back to my create table, so I executed this SQL query, that is create table. This is my table name, which is very unique one. And after that, in this one, it has 3 columns. Okay, one is the industry name, RIMCZ group, variables, blah blah, and these are the properties of my table. Yeah. And once the table is been created, what I did is I will go back to the PG admin, okay, and I will run this command, okay. So when I run this command, maybe my session have been out, but let me show you, okay. So if I run this command, so it will not connect. I will tell you why, okay. Why? Because if I go back to the so if I go back to my cluster, so you see the public accessibility is no, okay. Henceforth, it should time out now, yeah. So currently it is taking much time, but it will end up with the timeout, okay. But the connection will get timeout. But under the hood, okay. So under the hood, I run this command, yeah. I run this complete SQL command, and the database got created, and then later I run this command, yeah, and it has given me this output. You see whatever the output you have seen, yeah. All right. So this is like a second step after creating the PostgreSQL database, yeah. PostgreSQL, or nothing but RDS Aurora PostgreSQL version, serverless version 2 database. This is the step I did for my demo, yeah. All right. So now we are pretty much done from the destination side, yeah. So where are the destinations? So destination is RDS Aurora PostgreSQL serverless version 2. Now let's go back to the server side. Okay, let's go back to the source side. Okay, the source here is Amazon S3 bucket. Okay, for example, your application blah blah. Okay, any application which is which is using the Amazon S3 bucket and putting your data here. Okay, so for this case, what I did is I did nothing but I just went to the S3 bucket and I created a RDS Aurora serverless name called. Okay, this is my name I have given to the bucket and created a bucket. Now, if I go to the permissions inside this bucket, again, this bucket is being blocked from public access, but still my Lambda is able to access it. Why? How? Okay, why and how? Maybe you might have the questions. How? Because I have allowed. Okay, so in the bucket policies, I have allowed in a such a way that only my Lambda or only a role. Okay, only a role which I assign to a Lambda can access this S3 bucket. Okay, you see. So this is the policy I have added in the statement. You see the statement 1, and the effect is allow. The principal is nothing but this is the role. Okay, this is the IAM role, and the action is I have allowed all actions because only this role is being given access. Okay, that's the reason everything is been allowed. And the resource is nothing but it is giving not on the bucket but inside the bucket. Okay, I'm giving all permissions inside the bucket. Now I will take you to this ETL role. Okay, that also I need to walk you through. So if I go to the ETL role, so in the permissions, this is just an admin role. Okay, since this is a demo, I have given complete admin access. Maybe you can see here, but in the real production world, maybe you need to minimize the permissions. Okay, and in this one, if you see, this is where there is a very important step that is we need to maintain. Yeah, so we need to maintain the trust. Okay, the trusted entity equal to RDS Amazon.com. Okay, that is also a a kind of requirement here, okay, and a kind of a very important point to make a note, okay. Without this, maybe role will not communicate to the RDS, okay. That's the reason it is very important, yeah. And yeah, all right. So that is from the IAM side. Let's go back to the again back to the bucket. So on the bucket, I did nothing. You see the block, okay? The block on all public access, which is on nothing but it is block in the internet block. This S3 bucket cannot be accessed from the internet, okay? But we have created a policy such a way that AWS Lambda can access this S3 bucket, okay? That is the clause here. Now let me go back to the this diagram. Now we saw this one. Now we saw the S3 bucket, okay? Now let's go back to the AWS Lambda, yeah, and also I will take you to the VPC, okay? So if I open the VPC, all right, before I go next, before I go to the Lambda, I need to explain you how this VPC has been configured, okay? You see the VPC, okay? This VPC is hosting three things actually. One is Amazon S3 bucket endpoint, AWS Lambda, yeah? The Lambda is integrated within this, attached to this, okay? Generally, they will call it as a Lambda is attached to a VPC, nothing but, that Lambda will now run within the same VPC. Yeah, it is not internet. The Lambda will not have accessibility to the internet. Okay, it is just running within the same VPC, and it can communicate to the RDS Aurora PostgreSQL database. Without using any public connectivity. Yeah, it is just the traffic from AWS Lambda to the RDS is again, okay, is lying within the VPC network only. Yeah, it is not going outside. That is in simple layman terms explanation. Yeah. All right, I will go to the VPC. Inside the VPC, if you see, I select this one. Okay. So the CID range here is this is something like this. Okay, that is //16 one range. Okay. Yeah. So in this one we have three subnets as I explained. So three subnets are been tagged to the Lambda. I will show you later. Okay, so if I go to my subnets, so these are my subnets, and if you go to the route tables, okay, so these are the configurations probably you must need to follow to make this functionality working. Yeah, and you see in the route table we have three routes. One is local to this is default route, and then we have the internet gateway. I will tell you how does internet gateway come in, and after that this is the VPC endpoint connection which is happening. Yeah. Now earlier this IGW was not there, okay, but when I enabled VPC endpoint for S3 bucket, then this IGW started to create. Okay, it started to create. Yeah. Now I will go back to the endpoint. Okay, so how did I create an endpoint and what is the endpoint I created to access? Okay, so to access the S3 bucket, I created one endpoint, and if you can see here, yeah, the service name. Okay, the service name targets is nothing but S3 bucket belongs to AP Southeast 1 region. Okay, so how did I create this? I just went here and click on the create endpoint, give blah blah name here, then the service AWS service, yeah, and after that just type the service on which you want to create an endpoint, that is something like S3, yeah, and click enter. Then in this one we are choosing a gateway. What is the gateway? In the sense it is creating a tunnel on your VPC so that it can communicate to the data present in the S3 bucket in a very secure manner. Yeah, nothing but you are making the AWS S3 bucket endpoint to be available within the VPC. Yeah, so that is what the gateway does here. Okay, and rest all configuration. Okay, we need to choose the VPC, nothing but on which VPC we need to create a S3 bucket endpoint. That is a VPC where our Aurora DB is sitting. Yeah, and that is a default VPC I chosen. And finally I created an endpoint something like this. Okay, and that is what I mean to show you here. Okay, the endpoint of this Amazon S3 bucket is now exposed. Okay, nothing but available within the same VPC where my RDS Aurora DB is sitting. Similarly, my AWS Lambda is also sitting. I will take you to the next step. Okay, now we have discussed about VPC as well. Now final component. Okay, final component is very important component, because this is the thing which is actually processing the source data and putting into the RDS database. Okay, it is doing two jobs. Okay, one is it is downloading the file which comes and sits in Amazon S3 bucket dynamically, and extracts the data from there and uploads into RDS Aurora. Okay, I have written a logic with using the PostgreSQL Python module. I will explain you later in this scenario as well. Okay. Now first let me explain the how did I configure the AWS Lambda. So I went to the Amazon function. Okay, I went to the Lambda. In the function, I created a function called importing Lambda. Yeah. Anyways, all these component can be managed as an infrastructure as a code with using Terraform, or you can use your Python code, or you can use the CloudFormation template. Yeah, you can manage this infrastructure, but making the components connected together and making your solution working is very important. Okay, that is where my videos all focuses. So now I have created a Lambda. Yeah, while I created a Lambda, I leveraged, okay, I used the ARN, that is the role which I showed above. So that is a role I have used. Okay, and also I have attached a layer. Okay, so that is a layer. I will tell you what is that layer contains. Okay, and in next. Okay, so, and after that, there are multiple configurations I need to explain here. Okay, so how did I create first of all, let me show you how did I create a Lambda. I went to here, I click on the create function, author from the scratch, I gave a name and I selected a runtime. Okay, I will tell you. So since the the Python PSQL model which I have, it supports only Python 3.7. Okay, and that's the reason I have chosen runtime version equal to 3.7, even though it is almost nearer, which is a latest, which is a last version supported by the AWS. Okay, which is a risky, but maybe you can maybe you can get the Python module of PostgreSQL belongs to the 3.9, and you can change the runtime. Yeah. So that is a one suggestion. So here in my case, I use 3.7, and the architecture is cross 86 underscore 64. Yeah, and the execution role is nothing but the role which I shown you. I have chosen. Yeah. All right. And after that, once I created the Lambda, and it happened something like this. Now, not only that is not only enough. Okay, because here there are multiple configurations is missing, and code is also missing. Okay, code I will walk you through the later. Now let's go to the configurations. Okay, in the configurations, okay, in the configurations I did multiple things. Okay, let me come from the top. In the general configuration, okay, I went to the edit and I changed the memory and the runtime equal to something very big size. Okay, earlier it was something like very minimum one. Okay, like 128 MB was there. Now I increased into 1024, nothing but 1 GB. And similarly, ephemeral storage I also increased to 1 GB, because I'm downloading a file which is nearby 20 MB or 10 MB. Yeah, which is a greater than, so in that case, it is always recommended to have your memory greater than the file which you are downloading. Okay, for your information, for example, if you are downloading 2 GB file, yeah, I'm just telling. Yeah, so in such case, maybe you need to keep the memory size bit larger. Okay, so that Lambda can process very easily. Okay, it will not go in a hung state. Okay, that is recommended. On always keep the memory size greater than the file which you want to process. In my case, I'm just showing you for a 10 MB file. Yeah. All right. So in the ephemeral storage also, I'm keeping the same one. And the timeout, okay, the maximum timeout till now supported by AWS is 15 minutes, which is fair enough. Okay, because Python is very fast and it can accommodate that, that much data. For example, I have tested for 10 MB. It is creates in just in within 1 minute. Okay, nothing but within 30 seconds. Within 30 seconds, it can insert nearby 30,000 data into the Aurora DB. That is what my experience tells. So it is very fast. Might be it can accommodate your 200 MB or 100 MB within 5 minutes. Okay, that is my just a guess. Yeah, and after that existing role, this is what I made changes. Okay, this is the first change I made on my Lambda, and I go to the triggers. Okay, in triggers, let me go back to the figure here. So here you see the invokes. Okay, invokes are Lambda in the sense whenever somebody uploads a file, somebody is nothing but here application. Okay, or your business endpoints. Okay, or your business users. Okay, let's say business users directly uploads a file, that can be a use case. If your application dynamically creates a file and uploads into the S3 bucket, that's also a case. Okay, so in this case, yeah, whenever the file gets uploaded into S3 bucket, it should invoke a AWS Lambda. So that configuration I have did something like this. Okay, I will just go back to this one, and I clicked on the add trigger. Yeah, I clicked on the add trigger, and here in the trigger I chosen. So I know invocation in AWS is made very easy. So here I chosen this one, and I chosen my Aurora Aurora DB, Aurora database, and in this one I chosen all event creation. In the sense when any object is getting created in S3 bucket, just invoke my Lambda, and that is what the logic I have added here. Yeah. So if I will go back to the Lambda here, so I will go back to the Lambda and I will go back to the configurations again. And in trigger, you see, this is what it tells. Okay, whenever some object is created or event type is object is created, it will invoke a Lambda. Yeah. And that's what this diagram tells. In whenever there is a file upload into the Amazon S3 bucket. Okay, so in this scenario I'm using only CSV file. Okay, so here this scenario explains about how to handle the CSV file being uploaded into Amazon S3 bucket. Okay, let's say somebody is uploading S3 bucket, that will invoke my Lambda, and the Lambda will process that file, it will download, it will read the data, and it will upload into RDS Aurora PostgreSQL database one after the one. I will show you that logic as well now. Now we are done with the configuration number 2. Let's go to the configuration number 3. Yeah. Then the next one, let's go to the environmental variable. I have added a few environmental variable which is very needed for this function to work in. Yeah. One is database name. Okay, as I explained here. Yeah. So here you go. It is getting timed out. Yeah. All right. So my database name is vehicle. Yeah. So I have added vehicle here, and then host name. Okay. So the host name is nothing but my this one. Yeah. Writer instance name is a host name, and that is what been added into the environmental variable. Password is been stored, my table name is been stored, and the username is been stored. Okay, these are very secure, and credentials I have kept in environmental variable. But to make it very secure, what I recommend is keep this very secure, secret information in a either Terraform, maybe Terraform Vault, or maybe AWS native services, that is a secret manager. Yeah. So, and from there you can dynamically retrieve, that is also possible. Since this is a demo, I'm just setting in an environmental variable and keep getting these data from there only. Yeah. All right. So that is the third configurations, and let me go to the final configuration, that is VPC. Okay. So this is the configuration which makes this AWS Lambda attached to a VPC, in the sense it gets integrated within the VPC, and its runtime. Okay. Whatever it processes, it becomes within the VPC only. And how are we doing? We are doing by this configuration. Okay. So you go to the VPC, click on edit, and just select your default VPC which you have selected for RDS. Whatever the VPC you selected here, those VPC has to be selected here as well, and including the subnets and security groups. Okay, and by default VPC, these are the inbound rules are being applied on this one. Yeah. So here the source is for our VPC size. Yeah, this is our VPC size. Yeah. And the source, whenever the all communication within the network is allowed, and from this source, nothing but from this source, the port number 532 is allowed. Anyways, this will serve all the purpose. We don't need to have this 5432, but I just added for safer side. Yeah. All right, that is the fourth configuration I maintained on the AWS Lambda. All right, now let me go back to the figure again. So here we did this one. We checked the endpoint. We checked the AWS Lambda. Now that's the last point. Okay, the last point is I need to walk you through the code. Now if I go back to the code, so this is the one like big code. Okay, I have written like nearby 63 lines. Okay, nearby 70 lines. So that's a big code. I will just explain it. What does it actually does? Yeah. So that, let me explain you here from my Visual Studio Code. Anyways, this file I will be sharing my GitHub repo, and the GitHub repo link will be shared in this video's description. Please find this file from there, and maybe you can use it while you are trying to achieve this scenario from your side. All right. So in this one, I'm importing multiple modules of Python. One is the JSON. Then the next one is Python SysOps. So nothing but PS SQL module for Python. Yeah, the Python module belongs to PS SQL. So that is a PSysOps2. Okay, that is the module name. And then we are importing the OS because I need to deal with the environmental variable. Then we are also using the Boto3 because I need to download the S3 bucket with using Boto3. Then I'm also using the CSV because I need to read the CSV file which is getting uploaded into S3 bucket. Okay. All right. So the next one is I'm just writing my logic within a Lambda handler only. Here the parameter is event and context, which is the default parameters of a Lambda. And in that one we are set, we are just seeing what is the event format is. And after that, in the event I'm getting the record. Why I'm getting the record? In the sense because this Lambda is invoked by the put operation. Nothing but whenever the object gets put into this S3 bucket, whenever the object is being put here into this S3 bucket, so that creates an event, and that event will trigger the AWS Lambda, and that is where the flow follows. Yeah. And from that records, I'm just extracting the bucket name, and inside the bucket, what is the file name, okay, what is the file name which is uploaded, and finally creating a dynamic path, okay. Since the Lambda is, since the Lambda of version 3.7 is a Linux one, henceforth I am giving the path of Linux, that is a temp /temp is nothing but the root temp is nothing but, it's a path within the Linux, yeah. And we are finally printing the path, yeah. All right, so that is the thing it is doing. And the next one, what I'm doing is I'm creating a client of S3 bucket. With using that client, I'm downloading the file, okay. You see, I'm using the Boto 3 module and downloading the file. This is the bucket name, this is the S3 bucket key name, and this is the path, nothing but in which file the file has to be downloaded. And finally printing a message called, downloaded successfully. Now next comes the point where, I'm getting those credentials which is needed to connect to the, my PostgreSQL database. That is a DB name, host name, username, password, and table name. Yeah, that is nothing but which is coming from this one. Yeah. So yeah, all those data, like DB name, host name, password, table, username. So all these data will be retrieved from the Lambda's environmental variable. Again, I would recommend you to keep these secrets in a secret manager and get it downloaded from there. Okay, that is very secured one. Yeah. And the next one is connection, okay. So we are using the a PostgreSQL module of Python, and we are using the function called connect. In that one we are using these parameters like DB name, host name, port, username, password, okay. And finally we are establishing a connection, okay. We are establishing a connection to the database. That is where we are storing in a connection variable, yeah. And after that we are creating a cursor, okay. So cursor is nothing but, within the connection we have to set a cursor. Cursor is a function which will, help you to invoke the queries, okay. And here is the cursor is been created. Now comes the logic, okay. So here is the logic. So in this case I will just open that file meantime. So I'm just uploading very big file. So if I go to the file, so this is the file which I will be uploading, and I will show you that, what actually it does contains, okay. So if I go to this one, and you see this is the file I'm uploading, which is a 920 KB, which is nearby 10 MB. Yeah, it takes some time. Meantime I will just explain this. So yeah, where are we? So where we are here, I will just scroll down. Okay, so here what I am doing is we have just now about downloaded the CSV file. Now it is time to read that file. Nothing but, let's say it has 30 rows, 30,000 rows, maybe lakhs rows. Okay, it will read it. Yeah, maybe this scenario may be not suitable for, more than lakhs of rows. Okay, generally medium sized enterprises might be achieving this scenario within the lakhs rows. Okay, henceforth this code is definitely suitable for medium sized enterprises for sure, okay. And that's the reason I have written this logic in this way. But if your data is crossing then the limit, might be we need to think in another manner, okay. But definitely this will support file size of nearby 100 MB, 200 MB for sure, yeah. All right, and then yeah, what we are doing is I'm reading the CSV file, yeah. And you see this is the CSV file, and from the CSV file what I'm doing is we are reading the line by line, okay. As you know, CSV is nothing but comma separated values. So those the values will be read from here, and we are building a query here. We are building a S3 query, a SQL query, that is insert into this table, okay. This is our table as I shown you here, yeah. So this is my table which I created here. If I go down, so this is my table, yeah. I created with using leveraging the public access, yeah. All right, we'll go back to the code. So this is the query we are building. What is the query we are building is insert into this table where the column name, okay. As I said, I contain only 3 columns. These are my columns, and in that one we need to insert these values dynamically, because the column 1, okay, the column 1 of my CSV belongs to this column, and the column 2 is belongs to column 2, and column 3 is belongs to column 3, okay. That is I'm mapping, okay. I'm creating a dynamic insert query which maps the column of the CSV to the database, okay. We are mapping the column to column, okay. One first column belongs to first column of my table, the second column of CSV belongs to the second column of my table, third column of the CSV belongs to third column of my table, okay. And that is where the query is being dynamically generated, and you have to be very careful in this case, okay. And finally we are executing the query, nothing but for each record what I'm doing is I'm executing the insert operation. Here 30,000 times. Since this file contains 30,000 data, records, it is executes the insert query for 30,000. Yeah. I know that this may not be a good use case, but this is the best affordable way of handling your Aurora DB, especially PostgreSQL of version serverless. Okay, as of now. And then finally we are committing the connection, nothing but we are committing the changes to the database. Yeah. All right, and after that we are closing the cursor, and finally we are removing the path. Why are we removing the path? In the sense, the file which is downloaded from the S3 bucket, it will be locally stored in a AWS Lambda. Anyways, that file will be deleted by default from the AWS if you are not doing. Maybe it is always good for you to remove that file after your process is done, and that's the reason I have added a OS remove file as well. Anyways, okay, so this file will be shared in my GitHub repo, and the GitHub repo link will be shared in this video's description. Please find this file from there. Okay. All right, now what I did is I have walked you through the complete flow of this diagram. I explained each and inch. Okay, now time for a demo. All right, so now what we do is we go to the S3 bucket and we try to upload a file. When I upload a file, in the sense we go and upload this big size file, which is a 920 KB. It contains the 3 columns as well. Okay. All right, so what I do is I will go here, I will go to the upload, I go to the add files. Now let's assume that this is a business scenario is happening. In the sense, I'm a business user, I come to this S3 bucket and I'm uploading my business files, for example. Yeah. Now let's say you are the developer, you need to build this scenario. Then this is the real time scenario. For example, I'm the business user of your S3 bucket. Okay. I'm the user and I'm just uploading your business files. Yeah. And that file has been, for example, my job is till now here. Okay. I just go to the bucket and just upload a CSV file. My job is done. Now this automation solution, okay, this automation solution has to extract this file, process it and upload into Amazon, Aurora PostgreSQL Serverless version 2. And that is where the scenario coming. Okay. So let's go back to the, let's go back to the Lambda. Now, once the file is uploaded, this Lambda has to get invoked automatically. I will go to the monitor and I will open the CloudWatch logs. And since the RDS belongs to the belongs to the VPC, I cannot show you the data, but I can show you that it is inserted by referring the logs. Okay, and that becomes a end of our video. And that also concludes the the demo of this video. Okay, let's go and see if the data are being inserted into our RDS. Yeah, that is Aurora PostgreSQL. All right, the now time is 128. You see 128, yeah, and the latest log is this one. Okay, I'm opening that one only, and let's see. Okay, as I said, it is 30,000 records. Okay, so the log should be very big. Here you go. It looks like it has successfully uploaded. If I load it too many, okay, the logs are too many. I cannot scroll up. You see, right? It has uploaded too many things. But for your case, what I do is I will show you. It has worked successfully. Now, okay. Okay, what I show you is here is the query. Okay, so this is the query. It getting built. Yeah. And how does this gets output? Okay, so the whatever output you see is belongs to this for loop. Okay, and what are the things we are printing? We are printing the type of the type of the line. I think what is the type? Then what is the value in the line 0, 1, and 2? Finally printing the query and finally executing the query. Okay, so that is where we need to see and identify. So this is where the logic begins. Okay, first one, it is telling that I am the list. Okay, I am the record belongs to the CSV file and I am a list. And in that one, this is the first row, this is the second row, and this is the third row data. Okay, yeah, this is the third. Okay, this is the third row of the record. Yeah, and after that we are building a query, and the query looks something like this. Yeah, so this is the query. Yeah, insert into this table, and these are the column names: one column name, second column name, third column name, and value is nothing but this is the value to be inserted. Yeah, and if you can map, you can map it. Okay, you see the JD, JD grand total belongs to the second column, and the fixed tangible asset. Okay, that is belongs to the variable. Yeah, all right, and after the query is executed, and we are closing the connections. And we are also closing the connections. Okay, we are closing the cursors and the connections, and finally we are telling the wow executed. Okay, and finally we are removing the storage. Yeah, so when the flow In simple term, okay, if you're a good coder, you will understand this, the logic. Anyways, I'm not going to show you, the data because the database is not accessible from the internet. Yeah, from the query editor. Okay, so if I go to the query editor, maybe I can try to show you here. But under the hood, the scenario is achieved here. Okay, what is the scenario we have achieved here is, whenever whenever there is a scenario like where your business application stores, or whenever your business users or business partners stores a file of CSV type into the Amazon S3 bucket, and you need that to be copied into the RDS Aurora PostgreSQL serverless version 2. This is the scenario. Okay, when the bucket gets uploaded with the file and the Lambda gets extracted, Lambda extracts that file and reads the file and uploads into the RDS PostgreSQL one after the one. Yeah, and that's all. Okay, so yeah, so looks like it does not support. Anyways, we have successfully shown you the things to be shown in this way in this video, and finally we were able to show O executed output. Okay, if I show you that O executed code here, maybe I need to go back to the yeah, here. Okay, so O executed. Okay, this is the place, and finally it comes here and removes the file, and it is finally prints saying like file removed from the Lambda storage. Okay, where is the file removed from the Lambda storage logs? Yeah, so file removed from the Lambda storage logs, which is nothing but the script has run successfully without any error. Nothing but the data got inserted into the Amazon RDS PostgreSQL serverless version 2, which is a big name. Yeah, that's all. Okay, so that's all for now. Thank you very much for watching my videos. Kind request, please do subscribe my channel. That would really encourage me a lot. With that note, thank you. Thanks a lot.